go ahead and get started now officially in 5, 4, 3, 2, 1. Let's go. What's up, everybody? Welcome to the Comet ML Office Hours powered by the Artists of Data Science. It is Sunday, June 16th. I'm super excited to have all of you guys here. Welcome to the open office hours, man. I'm really happy to have everyone here. What's up to the friends in the audience? We've got Austin, Christoph, Asha, Jordan. Super excited to have all you guys here, man. So I think we should kick off with a question here. How about that, man? I'd love to go round robin and get everybody's perspective on this particular question. And it's, I think some of us here are on a varying spectrum of our data science journey. Some of us are just starting. Some of us have been in the game for, a year or two. Some of us are coming from an adjacent field like software engineering that, really earned our chops there and now transitioning into data science. And I'm wondering if you had to go back, we talked about this last week, talking about writing to yourself from a year ago. If you had to write something to yourself, or if you can contact yourself from a year ago, 2 years ago, to give yourself a piece of advice that would help you, what would that be? What would that be, right? So for me, I started my career initially, I was trying to be an actuary because, back in 2008, in 2008, 2009-ish, whenever it was, actuary was like the sexiest job. That was like the official sexy job. And it's changed a little bit. And if I could, I would tell myself way back in those days to maybe start picking up on some actual coding, learn how to develop and write software a little bit better. Because back then I was just toying around with R, toying around with SAS, and wasn't really, into implementing anything of that I did into any software system. So that's one piece of advice I'd give myself is start learning Python, because I remember taking classes with these are some, graduate level math classes, but they were with people from different disciplines. And I had a few friends who were in electrical engineering, and they were talking about using Python and how they would use Python to do timing tests for their chips or whatever that they're designing. And I wish I would have explored that a little bit further and dug a little bit deeper into that. Asha, what advice would you give yourself from a year, 2 years ago? Asha, you're on mute. Oh, there you go.
I'm unmuted now, I think. Definitely statistics. I keep saying it over and over. I ignored the statistics bit. That was one thing I wish I could have told myself to begin with, because that's basically all you need to do a lot of the time. So yeah, definitely the statistics is what I would have advised myself to learn.
And as a statistician myself, I second that. I think statistics is super important. Not like, even one step before that, probability theory. I think probability theory is one of the most underrated topics in data science that could get studied. Statistics is great, but none of that would make sense without any probability theory. How about you, Christoph? Let's go to Christoph. And guys, we're just getting warmed up here a little bit, just kind of get the conversation flowing. So if anybody has questions, go ahead and sorry, I accidentally muted Christoph, but if anybody has questions, just go ahead. Let me know right there in the chat. Let me know right there in the chat if you have questions, and then I'll add you to the queue. But right now we're just getting warmed up with the topic of what advice would you give yourself at the beginning of your career? Go for it, Christoph.
One piece of advice, I'd say find a way to contribute. Because at the beginning, we think we don't know enough. But even when we're starting, we already know, and while we're learning, we already know something that other people don't know. And I believe that we are ready. At the moment we learn something new, that's the great time to start contributing and sharing the knowledge. And I read that in this book, Give and Take, from Adam Grant, and that people believe that first they have to be good enough to start giving. And that's not really true. We can start giving also when we just start the journey. And that changed my mindset, and I started to look for some ways to contribute. But I did it only recently. Like, I'm active on Stack Overflow. I'm trying to answer some questions because I already know things that people don't know, and they're asking for it. And I believe that's a great way to learn and grow.
And that is absolutely beautifully put, Christoph. I love that. Absolutely love that. Right. I mean, living should be giving in a way, right? And you should learn so that you can educate. And it doesn't matter, like, if you're just starting out, whatever, like, put your perspective on it, put your spin on it, share it. Who cares, right? Like, just share it. I think we tend to overestimate the amount that we think other people know. You know what I mean? So just share it anyways, even if it seems completely obvious to you, like, oh man, everybody should know this. Um, Share it anyways, man. Who cares, right? Like, I mean, it could be brand new information to somebody. Absolutely love that. So hey, if you guys have any questions, go ahead, let me know. Let's get this kicked off, man. Let's get this kicked off. The Comet ML office hours powered by the Artists of Data Science, here to help you on your data science machine learning journey. Any type of questions related to the process whatsoever, me and my friends here will do our best to help you out. So if anybody has a question, feel free to unmute yourself, take the floor, and just go for it. Or if anybody wants to tell us about the bit of advice they would give themselves, let's hear that. Actually, let's hear from Austin. Yeah, I didn't call on Austin for this question. Go for it.
Yeah, sure. Thanks, Harpreet. Christoph, I really like that answer, and I think one of the things I was actually thinking about when Harpreet brought this question up was how I wish I had learned how to talk about what I do to like internal stakeholders. Basically, like that's one of the most interesting challenges from someone who does something kind of amorphous like content and community, and there are like limited metrics on that and how you report on that and how you talk about it. And I think from the beginning of my time at my previous job where I started doing this kind of work, I had invested more of my time in learning how to like report on what I do, communicate about what I do and why it matters, and be specific and learn how to like actually tease those things out. And I think it really connects to what you were saying about giving. And part of that for me was like writing, content and sharing it about what I was learning in building community and what I was learning about how you work with content and sort of kind of marketing and whatever else and relationship building and stuff. And so I think that's super important as it'll help, maybe someone else, but it can also be really helpful for you to hone your voice and hone how you talk about these things and how you down the road, write a report for a project that you have for work, right? I think these things all tie together. They're not all separate. There's this through line and connectivity between all that. So I just want to echo that and I say like that was actually sort of my idea too. So I'd love to hear that from you, Christoph. Appreciate that.
Yeah, absolutely love that. I remember when I first started posting on LinkedIn, I was really fearful. I was like, oh, what if somebody like, what if I say something wrong, or maybe I'm saying it incorrectly, and somebody comments on me and puts me on blast and tells me that, oh my God, you're so wrong. Yeah, there are people out there who are kind of malicious on LinkedIn who are just, doing a status trip, and they're on a high horse and they'll just nitpick and tear down every little thing that you post. There are people who do that, but that's just a small proportion of people. I think most people are grateful that you're sharing their knowledge, and if there is somebody who's making a correction or making an addition, all you got to do is, hey, thank you so much, I really appreciate that, really appreciate you guys helping me clarify my thoughts there, and just move on. I don't think you guys should be afraid of posting stuff on LinkedIn at all. Let's go to Ian for the next question. Ian, go for it. If you want to unmute yourself there. Ian typed the question out to me, so I guess we can just read the question and take it from there. But Ian, if at any point you want to hop on the call and just unmute yourself, feel free to do it. So what topics of statistics are most commonly used in the workplace? That depends very highly on which industry you're in, which use case you're dealing with, right? So that right there, vague question, but I could speak from my experience as a biostatistician, as a clinical trials statistician, right? at that level, a lot of what I was doing was experimental design, right? So I needed to make sure that I was randomizing patients to treatments in a you know, in a quote unquote good way to make sure that the test that I'm running is valid. And the kind of the analog to that in the data science world would be A/B testing and randomization schemes and things like that, right? So the design and analysis of experiments, hypothesis testing is something that will come up. Um, Things like that are very, very common. Now, when you talk about topics, right, like underneath all that, there's still like a whole body of knowledge that you need to know before you build up to that. So if I was to say not necessarily commonly used, but underpinning everything it is that we are doing in statistics and machine learning for the most part, there's topics like, law of large numbers, the central limit theorem, right? What is the expected value? What are probability distributions? What type of probability distribution is going to be suitable for a particular type of random variable? Things like that. So that's all like the big body of knowledge that's underneath everything else, right? The foundation. But I think day to day in data science, at least, statistics you're going to be using mostly is going to be within the realm of hypothesis testing, right? Or doing any type of statistical inference. So going from a sample and generalizing to the larger population, or trying to make a statement about a larger population from a sample. So Ian, if you got any other questions on that, I'm happy to answer. If my answer was a little bit too vague for you, then feel free to add some more specificity to your question. That being said, let's move on to the next question here. Or if anybody wants to chime in on that, let me know. Actually, let's go to Asha on this one. Asha, what have you been learning in statistics recently? What are some of the topics that you've been picking up?
I wanted actually to drag a whole book I bought in statistics. Hold on, if I can drag it here. Hold on. Yeah. So I went and bought a whole book of statistics. It's been that serious.
Yeah. Which book is that?
I'm trying to see where I am. Sorry, I covered it. I don't understand why I covered it, but it's quantitative techniques.
Yeah. Yeah. So I mean, like honestly, like I think the best way to prepare for the statistics and probability that you need to know for a career in data science is if you look at like the syllabus for the actuarial exam P, which is the exam that's strictly based on probability theory, you'll go through a whole list of really foundational topics that you're going to need to know. So that is one thing that I would recommend looking into. And then there's another actuarial exam. They change the exam names so often, but I think this one was called, when I took it, it was called 3LC. And that was just, it was just topics from mathematical statistics. So Ian, again, I'd be happy to dig into this further if you have any more details or things like that, or if you found my answer completely unhelpful, let me know. Asha, go for it.
So I think the best way to approach it for me was I went and I looked up a course, right, on statistics. Then I looked up at the particular topics, like how they were going to be taught. Then I knocked them out one by one by one. That would be the best way, because picking something is so random. Statistics is so wide. You never know what you might need and when you might need it. So I just decided to do the whole thing.
Yeah. I mean, that's definitely one way to go about it as well, if you have a lot of time. But I like that approach. I would recommend that approach because you'll learn it super in depth. But there's always that issue of, oh my God, there's so much to learn, so little time. You don't need to focus on everything, just kind of a bit of the foundations. So that being said, let's continue on here to Bhavika's question. Bhavika, are you still here? Yes, you are. Go for it, Bhavika.
Hey, so I recently shifted from India and I'm currently doing can you hear me? Am I audible?
Yeah.
All right. Yeah. So I just shifted from India and I am currently doing my master's in data science. And my entire course has been online. So I'm doing the whole course online. It's not as great as studying in person, but it's not bad. I secured an internship for the summer, which I'm working, and it's been great. But the problem is the first assignment that they gave me was building an ML model for a particular project. I'm very new to machine learning and I don't really know much about it. So I really want to know the step-by-step procedure as to what is it that I can, how is it that I can start? What can I do first? And then how do I move on from there?
All right, so let me ask you this. So you are working on a project and you're in an internship right now. Is that
Yes,
the
I
question?
just
Yeah.
started like 2
Yeah.
days ago.
So, I mean, this is just good advice kind of for your future. Don't feel bad about asking your seniors for help, right? Like, so if you're an intern, I'm guessing there are more senior level data scientists that you're working with. You should feel comfortable and confident going to them with questions and asking them for help, because the whole point of the internship, as an intern, you're not really there delivering results or delivering value. You're there to kind of learn the process and help out. So do you have senior data scientists or data scientists that are level up or 2 levels up from where you currently are in your internship?
Yes, I do.
All right. So that should be the first place you go for help, because that's what those people are there for, right? So those people are there to help you. So do not feel like afraid or have that imposter syndrome, like, oh my God, I got this internship, they're gonna find out I don't know shit and they're gonna fire me. No, that's not gonna happen, right? Like just make sure you're going to those resources to ask for help, because that's the best people to go to. Now, that being said, I mean, you got a data set. What have you done with it so far? Talk to me about what you've done with it already.
So I just tried doing a little bit of exploratory data analysis. So I tried, I found the interdependencies and I found what variables are, how is it that they're connected to each other. I figured what is the relationship between them. But that's about it. I don't really know much about ML, and this is, like I said, like it's new to me. So I'm really trying to just figure how to start with that, how to start with machine learning, basically
Mhm.
using YouTube videos, but I'm not really getting a lot of clarity on what to do next.
Yeah, so you did the first step, which is sounds like some exploratory data analysis, right? That's kind of what you've done. You've brought your whatever data, whether it's coming from a database or a CSV, you've got that into a pandas data frame, and then from that pandas data frame, you've done some high level exploration in the sense of looking at some univariate statistics, some summary statistics. Then you've done your plots, and now you've done, you're looking at relationships between features, you're looking at relationships from features to the target. Right now, have you done any type of feature selection, right? Have you looked at your features and said, okay, you know what, here's one feature that for every single row in my data set, this feature takes the value of 18, right? Okay, well, that's not really going to help any machine learning algorithm, learn anything new. So maybe I should just drop that feature. So that would be my second thing is
Select features.
yeah, select features, right? So if you look me up on LinkedIn, I just posted something recently that was a guide to data cleaning. So make sure you kind of are doing your data cleaning, your data preparation, exploring outliers, not necessarily just removing outliers, but understanding why they are outliers, right? And then look at the shape of each individual feature, univariate plots, univariate KDE plots, things like that, right? So now let's say you've explored your data, you've done a good job exploring data, right? Maybe you want to mix in some hypothesis tests or whatever, right? To do some insights. If you're trying to find some insights, you're doing some hypothesis testing and stuff like that. Let's just say you've done all that stuff, and now you're like, okay, I want to start trying to build a model. What are you doing? Are you doing a classification or are you doing a regression task?
So it will be classification. It's a classification task for sure.
Mhm.
We will have to do a little regression later, but the first part is classification for sure.
Okay, so now your task is to, do some type of classification, right? Now, do you have a baseline model in place? Have you constructed the simplest possible representation that will give you some type of result, right? A baseline model that you can then compare everything else that you do that's more complex against, right? So maybe your baseline model is, for every single And these are, a few valid baseline models. You want to start as simple as possible and get harder and harder, but maybe your first step as a baseline model for this classification algorithm is to say, I am going to select the most frequently occurring label for every single row, right? And then obviously you're going to have some type of, you've got to decide which metric it is that you're optimizing for. Like, I'm not sure in your case, right? If you're doing classification, like there's got to be some type of misclassification that is more dire than others, right? So whether that is the false negative or the false positive, whichever one is going to have the harshest implication, that's the metric that you want to kind of make sure you're optimizing for, right? So baseline model is simple, right? That's the simplest possible model that you can use that's going to give decent results. The first baseline, like we mentioned, you can just say, I'm going to predict the most frequently occurring label for every single row, right? Next, maybe you want to say, maybe you notice that there's some type of like groupings in your data set, right? And then maybe you want to pick the most frequently occurring label for that particular group and see how that works, right? So essentially you're just trying simple things just to see what happens. And then you can build a more complex model on top of that. I would start with something like a, logistic regression, right? If I'm doing classification, right? Logistic regression is nice and easy. There's not too many hyperparameters that you need to tune. And it gives you a good idea of, the predictive power that you have in your data set, right? Then from there, you can move on to more and more complex models, right? Or rather algorithms. Maybe you try random forest, maybe you try cat boost, gradient boost. I don't know. You can try a whole slew of different models, right? And then do these all without tuning any hyperparameters. Just do it with, default hyperparameters and see which one is giving you. So this is called spot checking. We're spot checking a number of different algorithms to see which one is the most promising, right? So you throw in a whole bunch of algorithms at the data to see which one's going to be the most promising. And then from there, whichever ones seem most promising, then you want to start doing some hyperparameter tuning using a tool such as Comet ML, right? So Comet ML is an experimentation tool that you can use to optimize hyperparameters for your algorithm, right? And then you see how well that stuff does, right? And so now you got a baseline model using the baseline set of features, right? Like just the raw features. You haven't done any feature engineering. I mean, you probably want to do the feature engineering before building out your models. So, I glossed over that part in the pipeline. So make sure you do that. But yeah, that's pretty much the workflow I would take at first, right?
Right.
At a high level. And then from there, you just drill down a little bit more, right? Maybe you notice, then you can start ensembling models together, right? Maybe saying that, if I do a majority, so here's what I mean by ensembling models. You could take, let's say you've got like, you spot checked 5 different algorithms. Of those 5 different algorithms, 3 of them seem the most promising. You do your hyperparameter tuning on those 3, and then 2 of those seem to be doing really, really good. Well, then you could average the results of those 2 to get you your final prediction, right? And just test and experiment, because this is all just experimentation, right? But just make sure you have like an analysis plan done beforehand, right? So that you don't just go down a black hole of just doing things over and over and over, right? So an analysis plan will be really helpful right at the start. So here's some follow-up questions here from Amber. So Amber, go ahead and unmute yourself.
Hello. Am I audible?
Yes.
So basically, my name is Amber Gupta.
Oh, Amber, not Amber. All right.
I'm from India. So basically, I have recently started learning data science or ML related field. But whenever I see any videos from Udemy or YouTube, At that time, it feels so easy. But whenever I apply it on some real world projects or search it on internet on how to start with some projects, then it is barely difficult to remember what to do now, means what to do first in the data set.
Yeah, you get that over time. Like the more and more you do it over and over and over again, the more and more you'll ingrain those neural pathways, right? So this is just kind of there's like a spectrum of expertise, right? So when you're a beginner, you need to repeat, just keep doing stuff, like, keep working on stuff over and over and over again. And then it just kind of becomes second nature. You start having to think less about it, right? So that's how you start remembering what to do, right? Like, just because this is this is part of the reason why I always say, like, certificates are great, boot camps are great, but you're not going to get anywhere unless you practice, right? You need that. You can read up and passively absorb principles as much as you want, but unless you practice your technique, you're never going to internalize what to do, right? You need to practice. You need to keep doing it over and over and over again. Umber, I'm going to pause there and see if you have any follow-up questions to that or follow-up comments.
No, sir, I have understood.
Christoph, go for it.
I just want to. Am I allowed to recommend a book?
Yes, absolutely.
That's my favorite book. That's my favorite
That's a good
single resource for learning machine learning. I've got the first edition. There is already the second one. It's called Hands-on Machine Learning with Scikit-learn and TensorFlow. And for me, it's like, I mean, most of what I've learned about machine learning comes from this book, and it's really hands-on, and theory is really well explained. It costs right now around $50, I believe, so it's not very cheap, but it's gonna guide you through these steps that Harpreet just mentioned, and it's just amazing. And it's always updated. There are notebooks available on GitHub, so you can just use the code that the author is using for this book.
Yeah.
So that would be my advice.
Yeah, it's a really, really good book. And if you're enterprising enough, you can probably find a PDF version floating around online somewhere. So people are asking, where can they get a video of this session? This is all going to be, hosted on my YouTube channel. So if by now you haven't been following my YouTube, then I wonder why not. Go over there, smash that like, subscribe, and tune in. And keep in mind that I gave Bhavik a high level overview, right? There's definitely nuances to every single step of the process, right? We completely gloss over feature engineering, right? I mean, and feature engineering is an important piece. And you're going to have to apply your domain knowledge. And if you don't have domain knowledge, that's completely okay. Go talk to the people in your company who do have domain knowledge, right? And figure out what you could do to help build out some of that real world complexity in the form of features, right? Because you got to understand, right? There's the real world, there's your model, in between is the data, but don't assume that the data is adequately capturing all of the complexities that are happening in the real world. You need to build out that complexity that is happening in the real world through new features, right? And you're going to have to be creative in this part. A lot of the bang for the buck in the modeling process comes from engineering helpful features, right? And there's entire courses on feature engineering out there, so I'm not going to really get too in depth in there, other than stating that it is important, and the features you engineer are going to be different for every use case, for every industry, right? But it is where I would focus most of my energy and most of my effort, right? And somebody's talking about, I think it was just Umber talking about how in the courses you take online, the boot camps, everything is super easy to do. You get good results. Like that doesn't happen in the real world that often, right? Like just because you're using machine learning does not imply that you're going to get like a absolute stellar prediction. But if you get a prediction that does better than chance, that does better than your baseline model, then you know you're headed in the right direction, right? And it's naive to think that you with your scikit-learn library, TensorFlow library is going to be able to adequately capture the complexity that happens in the real world, right? Just don't assume that that's going to happen with every problem that you work on, that you'll get like the 99% accuracy or anything like that. Some data sets, some problems work for that, and some problems don't. That's just because the real world is crazy. The real world is messy. Bhavik, guys, see you're unmuted there, so go for it.
Oh, sorry.
Oh, any follow-up questions or comments or anything like that?
No, I think this is great. The book that you were talking about, actually, I wanted to know, you have that on your LinkedIn? Is that it?
No, I posted something on LinkedIn, was just a guide on how to clean data. So the book Christoph's talking about, he posted a link right there at the bottom that you can look into. Asha said, definitely learn by practicing with real life data. Kaggle, yeah, Kaggle's helpful. I would say real life data, go to like an open data portal, right? That's where the real life data is at. Most governments, city governments have open data portals that you can go and pull data from.
Right.
Kaggle data, they're useful projects to work on, but I mean, I'd say that a lot of the work is kind of done up front. If from the Kaggle competitions I've seen, the data is kind of already clean. The data's already been nicely prepared for you, and you just got to be resourceful with feature engineering and things like that. Kaggle is a great way to practice, but don't get overly obsessed with trying to rank highest on the Kaggle competition rank. And to be honest, like in the real world, a lot of those solutions that you'll see in Kaggle will be difficult to implement and make work. So just keep that in mind. Don't keep Kaggle as like the gold standard for real life. But excellent point though, on that, Asha. Any other questions? Let's open it up. I see there's some comments in the chat, but it looks like we hit those comments. Jordan, how's it going, man? I saw Jordan was hanging out with us on Friday as well. How you doing, man?
I'm doing well. How are you doing?
I'm good, thank you, man. So you said you had a similar situation at work, man. Talk to me about that.
Yeah, so I mean, really the biggest problem, I don't know how specific I'm allowed to get, but the biggest problem is we have to like go from a target variable that's based on human behavior pricing to a price optimization. I mean, we do have market data, but it still seems kind of like a long shot in some ways, I guess. Not really sure how we would, yeah.
I mean, without going into details, you can still kind of describe the process for me. So like you're trying to optimize for price. Like in what sense are you trying to optimize for price?
It's actually like a renting cost, and we're trying to like optimize the. But you said without going into specifics. Wait, what was your question again? Sorry.
I mean, without giving me the secret sauce or company secrets, you could still kind of define the problem and what you're working on. But
sure,
like you said, your target is price, and you're trying to optimize for price, but optimize in what sense?
Oh, optimize gross margin. Gross margin.
Okay.
Yeah.
Yeah. So I mean, I do some research on that. Like gross profit modeling is a thing. So if you look into here, I'll pull it up real quick on Google. I'll show you what you can pull up. Yeah, pricing optimization is important stuff. But if we go here and you just do a Google search like this, right? We could put gross profit modeling, right? And then we could even put machine learning in quotes. Let's look only at PDFs. See what comes up. So this is kind of my I love Google searching, keyword searching, things like that. So looks like there was no hits on that. So gross profit, machine learning. There you go. You can improve earnings prediction, deep learning based corporate performance,
Okay.
credit risk. So there's different stuff like that. But I mean, you probably gross profit margins. Yeah, I don't have any resources for you off the top of my head, but it is a thing that exists that I've heard of. So you can dig a little bit deeper on that. But yeah, like you said, don't want to give too much secret sauce away.
Yeah, sure. Yeah.
Yeah, man. But if you got any other questions, let me know. I'll try to help as much as possible. Sagoon, go for it.
Hey, hi, Harpreet.
Hey, how's it going?
Hi, everyone. It's been a long while, right?
Yeah, it's been a while.
Yeah, I've been busy. It's been a very interesting year.
Yeah.
Okay, I'll give you the details later. Let me just go straight to the point. So I've been involved in, I've been busy doing interviews for a long while, and it's been interesting and tough, but we're getting better. So one of the sessions I had, it was a little painful because I was pretty much at the last leg before talking about negotiations and all that. And there's something they call a bar raiser, an interview step. So a random person from another part of the company comes around. Pretty much they call the person the nothing to lose guy or lady or person, meaning person has no stake, but just to come from another angle and interview the candidate besides the line manager. So I went to about 1, 2, 3, 4. I think I've done about gone to 3 stages already, and I passed. Even the first stage that I passed, and the last one was with the second barriers. And for me, it was quite tough. Why? Learning points for me, really, I was kind of sad, but learning points I did like to share is most of the projects I've been doing, excuse me, are primarily around classification. It's not my fault really. So most of the stuff I do at work are around classifications and all, but it then came from having a continuous value. So, which is why I don't really do often, and I don't have them by heart. And it was quite the in-depth. So you went into, I heard you talk about probability earlier. Yeah, so you went the probability angle also. You painted a scenario, what probability that this is that, can you model this from this? I was like, as I was standing and defending a thesis or something. Yeah, but one that stood out. So I pretty much was taking it in. So what I want to ask about is so you said, how will you turn a classification model, a classification problem to be solved by a numeric target? For example, like you have a churn model, now you want to predict churn. Definitely we use a binary classification yet, but how will we use a numeric target to predict churn? So that was the angle it came from. So I'd done a take-home test, and it was more like a churn project. It was fine, all good. Okay, based on what I've done, how will I change that into a numerical target to still predict churn? I was really,
So
yeah.
yeah, so I think what he was probably getting at is like when you're modeling churn, what you're really modeling is probability. So the output you'll get will be some type of probability, right? So you could just define like a threshold, right? Like if probability is greater than X%, then we classify this person as churn. If it's lower than X%, then we classify them as not churning. If I'm understanding the problem statement correctly. Was that kind of the situation? Like, I guess I'm trying to, so okay, let me try to regurgitate my understanding of what you're saying is, let's say we've got a bunch of features trying to classify whether or not somebody's going to churn, but the response of our model, it doesn't really just say yes or no, really. It's a continuous number between 0 and 1. Then how do we convert that to a classifier? Is that what the question was, or did I miss that completely?
So it's so the tax has already been done. So it's a yes or no, churn or not churn model. Yeah, but now he then goes to say, okay, this is fine. Now we want to do a second model, still the same problem to solve churn, but not using a classifier. So that's the angle came from. So I'm not, so the 1 or 0, yes, that was fine. But this time around, don't use a classifier to predict churn. Use a numerical target to predict churn. Like what you were leading towards also was, I was thinking, could it be to pretty much use a proper function in the cycling method and get the percentage. But I wasn't too sure of that. So I wasn't sure. I didn't even say that, but it didn't look like what he was looking for. So let me just try that and see if anybody had any ideas around that. So my thinking was, so my answer back to him was, okay, based on the features that that stood out during my feature selection, I pretty much go back and look at the numerical, a non-categorical feature that I can use, like how many orders a person placed over a period of time. That kind of feature, use that to compute some form of value. Then now use that as a target. So if this is higher, then there's a high likelihood that this person is not going to churn. If this number is lower, there's a high likelihood this person is going to churn. So that was the base of that angle I came from gave team, but I'm not sure it was what he was looking for. I could have been right, but he didn't tell me if I was right or wrong. But it just so I'm just trying to figure out if.
I mean, based on what you're telling me, like if I was going to model churn and the target was numeric, then I would hope that the target would be some, that we're modeling something that's between 0 and 1 if it's a probability. If not, then I mean, you could simply just say some threshold value, right? Our target is numeric, great. If it's numeric above this value, I'm gonna set a threshold, right? If it's whatever number I get, if it's above this, then I'm gonna say they're churning. If it's below this, then I'll say they're not gonna churn. That's how I would think about doing that. I don't know if that's helpful or not, but I mean, if I could point you to a resource that might be helpful for you, there's Carl Gold. He wrote the book Fighting Churn with Python or something like that, or Fighting Churn with Data Science. And he does these like live stream sessions on Twitch that are really interesting, of him just essentially coding live on the spot. I think that's the link right there. But Carl Gold, he wrote the book Fighting Churn with Data or something like that, which is helpful, which maybe you should look into if this is a problem that's still lingering. But yeah, hopefully that was helpful, man. I'm not sure if I really understood the statement there.
No problem. I'll check out the link.
Yeah.
I'll let you know.
Yeah, definitely, man. Well, thanks for hanging out, man. I'll see if I can, while the next person's asking the question, whatever, I'll see if I could find you the link to that to Carl's GitHub as well, because he's got some awesome content. I think the entire book is pretty much for free on his GitHub. That being said, let's see if anybody else has any questions or anything. Thanks for swinging by, Sagoon. And he is out there getting his fitness on. He's either running or biking or, deadlifting cars. If anybody has any questions, go ahead, let me know by just unmuting yourself and taking the floor. Now is the time. And while I stall, I'm going to look up Carl Gold's book to hook you guys up with his GitHub. I did an interview with Carl Gold on my podcast, and we talked all about how to do feature engineering for churn modeling and what type of churn models he would use as baselines and things like that. So look up the interview I did with Carl Gold on the podcast. There's a lot of great tips there for how to work on churn modeling problems. And I found his GitHub right here. I'll go ahead and link it. Fighting Churn with Data. That's the name of his book by Manning Publications. Yeah, somebody already linked it there. Awesome. Thank you, Bhavika. Appreciate that. Awesome. Hey, anybody else have questions? Let me know. Now is the time, my friends. Now is the time. I don't see any questions up or anything. All right. Well, let's see what's going on here with Sid. Sid, my friend, how you doing? I'm just gonna randomly call on people now. If nobody asks questions, you just get randomly start taking the floor here. Sid, my friend, how you doing? All right. It's a good thing that I truncate silences on the podcast episode so that those parts are cut out. Go for it, Christoph.
I've got another question about reading, actually, because you always say that we are much more than data scientists, and I totally agree with that. And I like that, like any of us likes reading. And I had this thought this week that some books are like, they have like 200, 300 pages, but the main points you could easily fit in like 5 pages or single blog post. And my question is, like reading blogs again versus reading books. Is it really necessary to read books, or if yes, what kind of books? Yeah, that's my question actually.
Yeah, I know exactly what you're talking about. Like some books, you see this a lot with business books. There's like a few main points that they can probably get across in sub 100 pages, but they just go on with example after example to illustrate and drive home the point. So I see that a lot with books, absolutely. And I think Austin probably would be a good validator for this. But when people are publishing books and stuff, right? Doesn't the publication company want to have something like substantive? If somebody's paying like $25, then it should be like X number of pages. Like I noticed that a lot. But here's kind of my philosophy, right? Like I'll pick up a book, like, and I love books. Books are my go-to, just because when I read, I'm very distractible, and it's helpful for me to get off of devices and just read off of paper books, like physical books. My take on this is kind of as follows. Like if I buy a book, if I got a book and I open the book, like I don't really have an attachment to finishing reading the book, right? Like, nor do I go into reading the book with the notion, like I don't read books like I used to in high school, in the sense that oh my god, I got to read this book because I'm going to be tested on all these random things, so I better read everything and take all these bunch of notes and be super thorough and blah 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 blah. Like, no, I don't really read books like that either. I just read just to get ideas, right? Like I think my brain as a garden, right? I'm just getting nutrients in there in the form of books. So I don't really care about finishing a book. Like I'll jump around a book. Like I'll take a book, I'll read it. I'm like, okay, great. This chapter is great. I think I kind of get the main point of what he's trying to say in this chapter. Let me just skip ahead. I won't even necessarily start at the beginning of the book. I'll start reading the intro, then I'll read the conclusion. Because in the intro, they'll say, oh, in this part of the book, I'm talking about this. In this part of the book, I'm talking about this. And then the conclusion will kind of wrap everything up. And then based on what I find interesting from the intro and the conclusion, then I'll go hop around in the middle and see what I like, right? There's zero attachment whatsoever to finishing or completing the book. Like I don't even care. If I really like the book, or if I really like the ideas from a book, then I will look for talks that the author has done. Maybe they've done talks at Google Talks, maybe they've done TED Talks, and I'll try to get exposed to it from different angles, or I'll try to find podcasts that the author has been on just to get more and more of those ideas, because then that really helps me really see the material from all different angles. I mean, in terms of what types of books you quote unquote should read, I hate the word should, first of all. Like I genuinely don't like should. I hate when people tell me what I should do. Like should, yeah, you will never hear me talk about should. I'll never tell anyone what they should or should not do. There is no such thing as should. That's complete BS. And I mean, I read a wide range of books, right? Like, I mean, I got Building a Story Brand here by Donald Miller. Like, it's relevant to kind of what I'm doing with my entrepreneurial initiatives. Like I'm, building a brand. So that's relevant to me. like how to solve it. Like, right, I'm trying to become better problem solvers. I got how to solve it right here. I'm trying to modify behavior for myself because I notice that there's some things that that I don't like that I do. So I'm reading Tiny Habits to help me figure out how to change some of these behaviors that I don't like. I love philosophy, so I'm reading a lot of philosophy. So, you know, right now I've been primarily into Eastern philosophy. So Bruce Lee's Striking Thoughts is amazing. I've got books on my Audible that I listen to while I'm walking. Two of them I was listening to this week was The Practicing Mind and then The Unfettered Mind. So like I'll just read whatever I'm interested in, right? Because at the end of the day, like that's what life is all about, just exploring whatever you're interested in. Go for it, Christoph.
Just a quick question. Is this Tiny Habits somehow connected with Atomic Habits?
Different author, but same, very similar concepts. Yeah, very same, similar type of concepts. So,
Okay.
yeah.
Just a few comments to what you said. I also hate should and of course must. This
Yes.
is like the another one. I replace them with want.
Yes, yes.
Or don't
yes.
want.
Yeah, I mean, it's interesting. So, I mean, I've been reflecting on this all week, but Bruce Lee talks about it here. Is versus should. What is and what should be. What is more important than what should be. Too many people are looking at what is from a position of thinking what should be. And I mean, this isn't a philosophy show. I mean, it could be any show that I want it to be because I'm the host, but I'm not going to get into philosophy here right now. But if you want to, we can explore this is versus should. And I mean, I'll leave that up to you
Maybe
guys.
not today.
Yeah, I'll leave that entirely up to you guys.
Okay.
Asha, Meditations by Marcus Aurelius. Oh my God, yes. So Stoic philosophy and is like very near and dear to my heart. So Marcus Aurelius Meditations is a amazing book. It's essentially a book of aphorisms. The translation of the book I like the best is the modern translation. I can't even remember the name of the person that did the modern translation, but it's the Penguin Random House version. And Asha, I will link you to something that you might like in the chat. Akira the Dawn took Meditations book 1 by Marcus Aurelius and made that into an album, which is freaking amazing. Let's go to Austin and see what Austin has to say.
Yeah, so I think in terms of reading, I think one of the things that caught up with me when I was in grad school doing poetry writing is we had a course on like the construction of the poetry book. And for that, we ended up just reading a bunch of books and then having seminars on them and how they were constructed and things like that. And as I worked through them, I sort of got away from the initial impetus to read poetry or read for joy or things like that, because I was consuming them to try to understand how to put together my own book. And as a process of that, I was not taking in the actual language and how the lines are structured and how all that kind of stuff. So I think understanding, like, I think there's a function to that. I don't mean to dismiss that type of reading where you're reading in a functional way, but I think like understanding when you go into a book, like, what am I looking to get out of? Like, what am I looking to do with this? Am I just looking to enjoy it? Am I looking to like get some key top line things? And then that kind of allows you to define how you want to engage with it, or how how you're comfortable engaging with it. Like if it's just a novel, like, and you want the richness of the language and plot and characters, then yeah, I like set out to read it and then, evaluate that way. But if it's, otherwise, I think it's understanding kind of asking yourself what you're looking for out of a certain text before you engage with it. And that can be helpful, just defining sort of an objective, just like you would in any other sort of project or undertaking.
Yeah, I love that. Like going into this book, like here's what it is that I'm hoping to gain from it. And, if I get it, great. If not, then you know what? I did not learn anything less than what I knew before I started reading it. So it's all good anyways. Win-win situation. I'm curious to hear from anybody else in the audience. How are you guys reading books? What are you reading? I mean, let's hear from Bhavika, because why not? Let's
So there's this book, Hi, My Name is Awesome. It's called Hi, My Name is Awesome. And it's basically based on how to name your companies and what names basically catch attention. And it's a great book for anybody who wants to build their own brand or something like that. I think that'll be a great book for you as well. So yeah, I'm reading that book. Um, apart from that, there is another book which I'm reading right now. There's a couple of books actually. There's Super Coach, there's The Magic of Thinking Big. These are like just basic books, but I am focusing on my data science journey. So I read a lot of Python and data science right now, apart from these books.
I think what is really helpful and great advice for a data scientist as well, right? Is read books that are in our field that aren't necessarily textbooks, right? So read books like Nate Silver's The Signal and the Noise, or Algorithms to Live By. That's a great book. The Model Thinker is a great book. Just reading up books off my shelf
Can you
here.
post the names?
Mhm.
I won't be
Yeah.
able to.
Yeah. So The Signal and the Noise by Nate Silver is all about why some predictions work and why some predictions don't. That's an excellent read. I just finished reading Shape by Jordan Ellenberg. He also wrote How Not to Be Wrong, Power of Mathematical Thinking. So just books in our field that are about math and about statistics and about data, but written for a popular audience. It really helps drill some of the concepts into your mind, I think, more intuitively. Naked Statistics by Charles Whelan. That's a great book. You can listen to the interview I did with him on my podcast. The Model Thinker, I mentioned that. Excellent book. You can also listen to the interview I did with Scott E. Page on my podcast. The Book of Why. That is an amazing book that is making me rethink the way that I've been doing statistics my entire life. It's all about causal inference and causal reasoning. Books like that come at what you are learning from a non-textbook type of way. But yeah, one of my favorite ones, though, I'll say it again, Algorithms to Live By. That book is freaking amazing. It's called The Computer Science of Human Decisions. And it, you'll get a more intuitive sense of what these things are that you're doing. So definitely recommend that book. But yeah, Asha, what are you reading, or how do you read, Asha? Like when you read a book, like, okay, barring technical books, barring textbooks, right? We have textbooks. Obviously, like the point of textbook is we want to learn how to do things. So we might go through it in order because we need that continuity. But when you're reading other books that are not textbook related books, like how is it that you read?
Okay. When it comes to textbooks, they're different, right? There are things like if it's a book on coding, I find, okay, let's say, for example, Python. There was a Python book I was reading that it doesn't have all the extra crap in between. It's very summarized that you go through from one end to the other so that you don't, it helps you. I mean, before when you're learning through, let's say,
Looks like Asha's having some connectivity issues there. So I'll go ahead and
you keep on meeting syntax that you've never met before. But when you go through a whole book, it's very hard to meet a syntax you haven't met before. But for the other books that I'm
Asha, like, sorry, I had to mute you there. It was very, very choppy. So my apologies for that. If you could type the name of that book that you're talking about, I'd love to put that in the show notes as well. You mentioned a book that was all about Python, kind of just getting right to the point. So that'd be very helpful, I think. Jordan reads a lot of Adam Smith and some Karl Marx, a couple of times through a philosophy course in econ philosophy. Nice. Yeah, I like that. My favorite type of philosophy is like ancient philosophy, like these philosophy from the last 300-400 years ago. It's interesting-ish, but I like the ancient stuff. I don't know why. Like for me, it's mostly Stoicism, Zen, Taoist philosophy. So stuff like that I find really, really interesting. Jordan.
Oh yeah, I also just took an emotional intelligence class through Yale, and I thought that was pretty great. It was not only therapeutic, but I think it was helpful.
Yeah, if you can link to that, that'd be awesome. Yeah, emotional intelligence. My friend Gilbert Eikelenboom, who was also on my podcast, guys, check out that episode, wrote a book called Analytical Skills for People Skills for Analytical Thinkers. Gilbert Eikelenboom, People Skills for Analytical Thinkers, which is all about emotional intelligence. It's a really, really good book. But yeah, if you could post that there right into the chat, that'll be awesome. LinkedIn Learning has a lot of awesome courses as well. So if you have LinkedIn Premium, you get access to LinkedIn Learning, and LinkedIn Learning has courses on all sorts of awesome and interesting stuff. Even Udemy has a lot of free courses on really cool topics like, you know, creativity and neuroscience and even emotional intelligence and things like that. So here is the link to the course. It was a Coursera course, Managing Emotions in Times of Uncertainty and Stress. Enroll for free on Coursera, so that is awesome. The Python Cookbook by David Beasley is the book that Asha was talking about, which is awesome. I've seen the Python Cookbook. That is a great book. Somebody I really like that come across recently was on YouTube, Finxter, Finxter. He has a lot of really cool stuff. He does this series which talks about the 64 built-in Python functions, which I noticed come up over and over again in coding interviews. So that's useful to know those built-in functions in Python. You'll have to rely on those so often during coding interviews that it's worth knowing them and knowing that they exist. So definitely make good use of them. Let's see if there's any other questions. Otherwise, we can begin to wrap it up. If there's any lingering questions from anything that we talked about earlier, Bhavika, let me know. I know we're getting a bit technical there. If you have questions on that, if anybody else has further questions on anything, Sagoon, sorry, I didn't really understand your question that much. Hopefully come into a data science dream job officer. I know you're part of that. We can drill a little bit deeper into that. Sid, if you got questions, let me know. Auntie, you know, Auntie's out there lifting cars above his head, doing backflips. All right, does not look like there's any other questions. So I guess we start to wind it down, guys. So hopefully you guys got a chance to tune into the most recent podcast episode I did that released on Friday with my good friend Arjun Sachdev, co-host of the Rising Laterally podcast. Keep in touch for keep tuned in to the podcast next week. I got an episode releasing with the one and only Steve Norrie. You guys might know who Steve Norrie is. He's quite a big deal on LinkedIn, so that'll be a good episode, man. I had a good time chatting with him. Later on this month, I've got an episode releasing with the one and only Kenji, so that's another awesome episode. I mean, just in general, man, this summer's a pretty stacked lineup for the podcast. If you guys don't mind me just telling you what I got coming up over the next month or so in terms of guests, I think you guys will find this interesting. So I've got, you know, like I mentioned, next week, Steve Norrie. The week after that, I've talked to Jamie Woodhouse. He is a philosopher and founder of this school of thought called sentientism, which is, you know, kind of like humanism mixed with some other really interesting types of philosophy. So definitely check that out. I really enjoyed that conversation. Also got that episode releasing with Ken G that I mentioned. That's on the 25th. Then I've got an episode with Jordan Ellenberg, author of Shape. That's on July 2nd. Then I got Barbara Oakley, author of A Mind for Numbers. She taught the class Learning How to Learn. That's on July 9th. I got James Altucher coming on the show July 16th. James Altucher is kind of a big deal. He's awesome. John Sviokla. So he wrote The Self-Made Billionaire Effect. Then I got Lillian Pearson, Jonathan Tesser, a couple other really cool people coming in as well. Beyond that I'll keep secret for right now. Christoph won't be able to make the next 3 to 4 sessions. Hey man, well, I'm gonna miss having you here. I really enjoy having you, your questions and commentary here, man. So hopefully you're going on. Where are you going? Are you going on vacation or doing anything interesting?
Yeah, just a lot of private stuff, so
Nice.
I don't feel like talking about.
Yeah. No worries, man. Well, Austin, go for it.
Yeah, I just wanted to say, Christoph, I'm starting to do those recaps every week. So, back to your discussion about reading the whole text versus checking out the blog post version, I'll definitely make sure I have the next 3 to 4 sessions up for you so you can check out some clips and keep in touch with what we're talking about. And I got some ideas for how I'm going to make those better too and more interactive a little bit with maybe some resources that we talk about and stuff like that. So just wanted to let you know those will be.
Yeah, definitely. And I'm excited for those write-ups. I'll be sharing them on my LinkedIn page. They're shared as part of my newsletter as well. So definitely keep an eye out for that. And don't forget, Bhavika, let me link you to Comet ML's. They've got a bunch of awesome tutorials that talk about the end-to-end data science pipeline. They got some awesome webinars as well, all about the end-to-end machine learning pipeline. Awesome resources for here, let me just pull up the website here. Actually, they got awesome resources for experimentation because you need to have a solid experimentation platform. Trust me, because otherwise life will just get messy. And Comet ML has that. So definitely check them out. Am I sharing the right screen? Which screen am I sharing? This one, yes. So go to comet.ml. And then if you go to menu here, sorry, not menu, where is the blog here? And they got a lot of awesome, cool stuff in here. Free webinars, case studies, tutorials. The webinars are really awesome. They have a webinar with like people from Uber talking about how they build their data science pipelines. And yeah, definitely a great product. I've been using it at work recently because I'm optimizing a production model. So yeah. So how do you start the machine learning research process? That was a good one. But the tutorials are key because they do end-to-end tutorials. So check this stuff out. They're also the folks who have been so generous enough to sponsor these sessions. So definitely check them out. All right, I think I stalled way more than enough because if there's a question, it would have come up by now. So thank you guys so much for coming to hang out. It's been a fun hour. Hopefully see you guys next week, same time, same link. So look forward to seeing you guys there. Guys, take care. Remember, you've got one life on this planet. Why not try to do something big? Cheers, everyone.
Thank you. Goodbye.